the cloud. You don't need to send the whole video itself, and anything. Even if it's audio or anything. I'll just show you one small demo of what I'm building into here. So just to give you a small heads up, so we'll be having here something called as embedded Linux. So embedded Linux, how many of you know what is embedded Linux, or anyone if you have worked with embedded systems prior? 1, 2, 3. Okay, cool. Yeah. So you might have used Jetson Nanos, Raspberry Pis, or any other microcontrollers, right? Yeah. Yeah. Cool. So yeah, you can deploy your OpenClaw wherever you have the embedded Linux running. So I'll just give you a small heads up on how embedded system hardware will be. So you'll have something called a SOM, which is system on module, which in a single module you'll have a CPU, RAM, ROM, and a processor and memory as well. And also you have something called a single board computer. Within the single board computer, you'll have something called as system on chip. In that system on chip, you'll have all the RAM, processors, microcontrollers built in within a single chip. So how it works between an agent and the hardware, if you may ask, in the Linux. So in the Linux, we'll have something called as operating system APIs and device drivers. So you can directly make use of the device drivers and the APIs in order to use the accessibility for the AI agent. So this is the flow which can be used. It can use a GPIO or I2C tools from the system shell, or it can use any higher level microcontroller programming language such as Python, C, embedded C, anything. So these are some of the ways which AI agent can communicate with your existing hardware. So I'll jump into the demo. So here I have a Claude Code setup running. So I actually wanted to show it in the OpenClaw itself. So I was not able to get my gateway started, so I had to switch to the Claude Code. So in this microcontroller, there is a matrix, LED matrix display. So what I have done is, I have fed it the STM32 datasheet with the pinouts along with how the QCS chip is communicating with the STM module. STM is nothing but a microcontroller. So I'll just switch to a different terminal. So it's your typical Linux terminal. So this will be okay. This thing is right now in this board itself. Okay. So here you have all the hardwares required, either the disk, and here also you can also get access to the LEDs. There are some RGB LEDs along with that you can control with this itself. So this is the main difference where you don't have it in your laptops. So I'll just open the Claude Code session and I'll change it to. So if you are comparing this Arduino with your laptop, means it just has like some 2 GB of memory, 2 GB of RAM, and like some 8-9 GB of storage. So it will be like running very slow. So the Claude has changed the LED matrix array. So it's written in a embedded C program. So once it has all the libraries with it, and it will just create a application and it will just execute it. This is the, yeah, you can can see a arrow is displayed. So you don't need much of a embedded knowledge to do this. Why I wanted to showcase it here is like if I compare like full stack development or any software development tasks with my embedded systems tasks, I can see like there are very lesser developments going on in the embedded field because also there are like very different platforms, very different chipsets, very different tools available for the tasks. Yeah, so here you have. Yeah, if you have any questions, then I take it. Sorry? It is actually running in the Docker itself. Yes. Yeah.
So, my doubt is that how did you set up this? Is there any software you can set up or something?
So the setting up is like as same as how you set it up in your laptop. The only difference in the embedded Linux is you will have just some few more connectors and few more directories which are hardware accessible. That's all. And you have to select the ARch64 or whatever architecture the CPU is there. And it's like just as is, you run the openclaw./install script, same as is.
You can make a website where it can, like simply you click some button and it automatically set up for your board. You can select any board, something like that. If you make it, it will be easier for people.
Correct. Yeah, that's what. Still, the embedded system development within the AI is like very backwards. Okay, so even like many open source companies and Edge AI, Edge Impulses, and all those companies are working towards this. But still, it's like very slow, is what I feel. Yeah, we can do that. We can set the websites and all. But correct. Yes, yes. Yes, it will be very, very easy. Correct.
What is the board?
What's the?
Can you tell what is that board that is used?
The board, yeah. This is some. It's Arduino Q. This is a collaboration between Arduino and Qualcomm. So it uses QRB2210 chipset.
The Arduino Q comes with the display, everything, or is there specific?
This is a LED matrix display. This is actually there is a it's nothing but a QRB2210 chipset from the Qualcomm plus STM32 microcontroller. So there is a communication between the STM32 as well as QRB2210 chipset. So the embedded Linux will be running in the Qualcomm platform, and the STM32 runs the embedded C program. Yeah. Yes, yes. It's a yeah. So correct. Say you have a remote place, okay, where you don't have any internet accessible. So this is where Edge AI or like you can deploy your AI model within this actually. So yeah, business possibilities are endless. Also, you might have saw some gadget. There's a small tracker. If you just click it here, it will just summarize you whatever it says. Yeah. Yeah.
Like, can this make something like it can place some text on it? Like, can it happen? Or in RGB colors, can it just create some small video, something like that, through the RGB LEDs?
Yeah, we can do that. Yeah. It's.
You can try making it like a small video with colors, like some colors and like some face comes in.
Yeah, we can do that, but that requires a lot of hardware accessibility for this. Right now, it's like very limited.
RGB, right?
No, it's not RGB. It's just blue LED. There are actually RGB LEDs here, which will show you the processes. It will show you what QRB is running and all those things. Here you can see there are 4 RGB LEDs. Correct. Yes.
It shows like that. I'm telling like
The scrolling one, right? Yeah, we can do that. Yeah.
Because I see that in that figure.
Correct, correct. You can do the scrolling display one also, and also you can show some animations also.
Like the stick fight game, right?
Yes. Yeah, so any doubts? Recently, I saw one.
It's showing some.
One tech guy had made a OpenClaw project with. He can see whatever is. Right.
Just direct it to the remote.
So yeah, you can also utilize it for smart home applications. Like you can also integrate a CSI camera, and it doesn't require the video to be sent to the cloud for processing. It can actually handle the video processing within the chipsets itself. So you can directly collect the context from the video, and you can just put it to your agent. No need of burning lot of tokens for this.